Okay. This week we're gonna learn clustering. And now let's start our lecture and see what is clustering and how we can do clustering on our data set that we have. I'm sharing my screen. Okay, now you see my page. Okay, we are in week 10 and we are recording. Yep. Yes, we are recording. This week we're gonna go and learn clustering. Let's see what is clustering. Okay, clustering is dividing data set to groups by similarities. Okay, we call this clustering. Clustering means grouping data according to their similarity. Let's see why we need to use clustering, where we use that in like daily life that we have. Do we have some example of this clustering or not? And then we go through algorithm and at the end, how to code this clustering, okay? So clustering is grouping data set according to their similarity. Let's give example. For example, we go to a shopping, to grocery shopping, okay? I want to make sure that we are recording. Okay, we are recording. We go to a grocery shop, okay? And inside the grocery shop, they have different parts. For example, they have like vegetables part, they have fruit parts, okay? They separated items. They separated that items that they have according to their similarity that they have, okay? And inside like fruit part and groups, and still we have, okay, one part they have onion, the other part they have like apples, and also inside the apple parts or apple group, they put separate like red apples in one side, then like yellow apple, green apples in other side, probably according to price, according to color, or whatever that they design it, and they grouped everything, okay? Cluster is similar things. For example, you have Netflix and keep watching movies. This Netflix send you some all the time recommend movies, and according to what they can send you this recommendation movies, according to the history and what you use, they use clustering algorithm, okay, for data analysts to understand, okay, what you like, what is your favorite movies, and according to that they put you to a group and then keep sending like related movies. And for social media, same thing, that recommended movies or videos coming up, and that kind of like for marketing, customer shopping behavior they try to understand, and that kind of things. Okay, let's go and let me write here for you more about clustering. We have three types of clustering, the way that we code and we use the algorithm. Okay, we have three type clustering. That's where I think. Okay, maybe this. Okay, we have three type of clustering. Okay, let's see what they are. First type of clustering, we call it exclusive clustering, okay? We call the first one exclusive clustering, okay? What is this exclusive clustering? We either call it exclusive clustering or hard clustering, okay? In exclusive clustering, one item or items exclusively belong to one group, okay? Like one, for example, I give you some like example here. You have some points, some data, some items, or whatever, okay? And this kind of, and we want to cluster them, okay, according whatever we want. In clustering, we come up and group according to their similarity. Okay, here I say, okay, this is one cluster and this one is one cluster. And in exclusive clustering, items belong to one group. They cannot belong to both groups or something, okay? For example, here we have k-means clustering. For first one, we have k-means clustering, which today we're gonna learn it. And the second one is overlapping clustering, okay? The second one is overlapping clustering. Overlapping clustering or soft clustering. So here, in overlapping clustering, the data point can belong to multiple clustering, okay? They can belong to multiple clustering. One item can be in both clusters according to their similarity, okay? For second one, we have some methods or algorithm, which is C-means clustering. And number three, we have hierarchical, I think. I'm not sure if I pronounce it correctly or not. Hierarchical clustering, okay? In hierarchical clustering, actually, I'm gonna give one example. For example, we have alphabets, okay? We have A, B, C, D, E, F, okay? And we need to group them, we need to cluster them, okay? So we're gonna come and say, okay, A, B is similar to each other. And we create this line, I forgot the name of this line, that what we call it. So or our program or either the algorithm behind it, okay, create that line, show the relation among that two items, okay? A is similar to B, and then I can, okay, B is similar to E. And after that, okay, I can say C also similar to A and B, okay? And it can grow, okay? The level of these lines is important. For example, now A, B, D, E is in one level, okay? And then C was clustered in A, B, and then here I can say F, D, E is similar, and then I can say, okay, they're all alphabet. They can go under one group, similar group, okay? And that kind of things. They can all, like in hierarchical clustering, they can all like place under one big cluster, okay, one group. Now let's go and talk about k-means that we're gonna learn today more, okay? We're gonna learn this. We're gonna learn this k-means clustering today. Let's talk a little more about clustering, okay? So in k-means cluster, we group items according to their similarity, and one item can just be replaced in one group, okay? And k here, the k here represents number of cluster, number of group that you have. For example, I want to have 4, I want to have 2, and something like that, okay? Let's give example here. For example, we have, I want to just explain this, therefore you understand the logic, the algorithm behind that one, okay? And each time you do clustering, you understand why you need to do that, okay? For example, you have a lot of clothes, okay? Dirty clothes, then you want to take them to like laundry and wash them, okay? Here we have a lot of clothes, a lot of dirty clothes, okay? They're too much. And we need to put them in multiple machine. But how are we gonna separate them? How we gonna group them, okay? Now here I do a clustering. So I come up and like divide them, group them according to some features or similarity that they have. So clothes have some similarity, for example, color, okay? They have different color, and dirt, like some of them is too much dirty, some of them little, like that, okay? And also material, so each one's material is different. For example, some of them are jeans, some of them are tops. So top is like softer than jeans and that kind of things. And some of them, like we can just wash them in cold water, and like some we need to wash them in cold. Some of them like warm, or we can use hot water and that kind of thing. According to that, I come up and make them 3 groups, okay, 3 cluster, and say, okay, my first group can be jeans and the clothes that they are thick or heavy or big or like they're too much dirty, and my second group can be like top and that kind of things that they are like lighter or less dirtier and that kind of things. This is the way that we do clustering in daily routine, okay? But let's see how computer and how our Python code gonna do that, okay? Here, this is k means clustering algorithm, okay? Algorithm. This is algorithm behind this clustering that now I'm gonna explain for you. For example, we have data point, okay? We have data point. I have one data point here, the other one here, the other one here, 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 and some here and here, okay? How program or algorithm, math algorithm behind this k-means clustering works, okay? First here, I'm gonna say, and I'm gonna select the number of k. First, we select number of k. Okay, how many it's gonna be? I'm gonna say like 3. I want to make them in 3 cluster. Okay. And second one, program, or according to algorithm, randomly 3 points picked up as a cluster, as a centroid. Okay, for example, we said we need to have 3. Okay, here I'm gonna come up and say, okay, my first point, like randomly, I need to pick up some point as a centroid, or the point that this cluster is supposed to be k. Okay, I put 3 points here and I call them centroid. Okay? After that, okay, we randomly we select 3 distinct data point, okay? data point as centroid. And for the third one, what we do, see, this is my first point, okay? This is my first point. We come up and start from the first point, or algorithm, or Python use that one, okay? And comes measure the distance between the first point to the first centroid, okay? So here, measure distance between first point to first centroid, okay? And in level 4, we do measuring mean, average, okay? Measuring mean between my point and that centroid, okay? For example, now with yellow color, I measure that and my mean is there, okay? I put mean there. And then we continue to measure this point with all other centroid, okay? So here I measured with the second one, I measure with the third one, and for all of them, I put a mean, okay? And after that, I do this for the second point, okay? I did hold for first point, now second point, okay? For the second point, this is my second point with 1. But the average that here I calculate include second point and also the first point, okay, through the centroid. Okay, here my maybe my mean gonna change a little bit, comes here, and I continue this measuring the second point with the second centroid and then third centroid, and keep measuring that mean, okay? And we continue this through the end of all points. We go through the all end of points that we have in our data set. So this is called one cluster, okay? One time, like we just did cluster. And at the end, when we're done, what they do, okay, total variation within the cluster, the algorithm need to calculate total variation, okay? At the end, like 5, I'm gonna say we're gonna calculate sum of variation, okay? Variation mean the total distance between each each centroid that we had, okay? Which we show this variation like this, or in coding we just write as something like this, okay? This is variation, and we calculate this variation. And this was just one time. Computer or algorithm keep doing this one, so it go back and select number of, no, not selecting number of k, it's gonna remain 3 all the time. I'll jump to the 2, randomly select 3 distance, 3 distinct data point, okay? This randomly pick up. It's gonna change, like first I choose this red points here, now I'm gonna choose it here, here, and here. I repeat, hold all the process that we went, and again, like calculating that sum of variation, and go through this step and process, going, repeating till this random selecting 3 points goes through all the points that we have in our data set. And after that, program or algorithm comes up and compare the variation from each clustering that we did and compare them. The most smallest variation is the best clustering, okay? The less difference, and the smallest variation here is that distance. When the distance is smaller, that means that clustering was the best, that grouping was the best grouping that we did, okay? This is that logic behind the coding, okay? We can, so in coding, we do this clustering in 2 ways. either we code it, we write that algorithm. So for writing that algorithm, okay, first we randomly choose k. No. First we choose k. We say k equal 4 or how many group that we want, and then randomly we picked up that centroid and then computing that k new centroid to all points, and then keep repeating that one. Okay. In Python, either we can go and call libraries. So engineers already create this algorithm for us. We can go and just use that function, call the libraries, and keep using k-means clustering or other clustering. So let's go and start do coding. Okay, I'm gonna stop sharing this part and go share my screen. Open your Jupyter and open the previous file that we worked on it. We're going to continue working on the same file as week 9. Week 9, section 1. Okay. Let's do call that libraries and start using creating our k-mean cluster. Okay, this is week 10, and we want to do k-means clustering. Okay. First thing for k-means clustering is importing our data. Okay. We imported the Excel sheet an Excel file into this code already. Now we're gonna go and call libraries where my k-means function exists there. Okay. For clustering, we're gonna use sklearn. Okay, sklearn library. I'm gonna say from sklearn dot cluster import k. Okay. We have cluster module inside sklearn library, and from that we import k-means. And this is the only thing that we need. Yes. We imported our data set. Now there is 3 important functions which for clustering repeatedly we keep using, and all the time to do clustering on your data you just need to use these 3 function. Okay. First thing is k-means function. Okay. What we learned, we said quickly we're gonna just tell how many cluster we want to have, how many group we want to have. Okay. I'm gonna call this k-means function. Okay. K-means function, open close parenthesis, and inside this parenthesis I'm gonna put the number that my clusters want to be, like n underscore clusters equal like what? Equal 4, equal 5, equal 2, but yeah. Set. The next function is fit function. Okay, fit function. I want to feed the data, the whole data that I import to this Python program. I'm gonna feed and put them in k-means. Okay, function. Okay, I'm gonna say like on this one. So this line is important. Okay, I'm gonna repeat this line and say from this k-means, like k-means function which has 4 cluster, okay, feed this data to it. I'm gonna say something like that, write a code like that, okay? We're gonna say repeat exactly line we wrote, okay? I'm gonna say, okay, k-means function which has 4 clusters, okay, equal 4 dot fit what? Fit the data set that I have. Whatever the name of your file is, which we imported here. See my file here, okay, my file. We want to use that one, okay. I'm gonna say like my file here. And the third one, the third function, okay, we use k-means function, we use fit function, and now we need to predict. We want to tell our program, okay, now you did clustering and fit the data, now go and predict my cluster, okay? Choose and like cluster them, put them inside the groups. For that one, we use predict function, okay? I'm gonna say exactly same thing, same line of the code from this k-means function, which has 4 cluster, predict this data. K means and underscore clusters equal 4 dot predict. Predict one, predict what? Predict my file, okay? Now, since we need to keep this line, I can just put a variable instead of that and make it short and keep using that variable, okay? Put a like short little variable, whatever you want, and keep using that variable. So I'm gonna create a variable inside this line of the code and keep using that one. What we can put like k-means, something like that. K-mean equal. And now instead of repeating this line all the time, I'm just gonna put k-mean. K-mean. Like this, okay? I have my file and everything. Now, what we do, I want to pick up 2 columns, okay? Put them 2 columns. So a scatter plot is something that all the time coming up with these k-means. Then we use, okay? I'm gonna use that a scatter plot. Put my data set into that one, and let's see how it's like predicted. So we can show it with colors, okay? Like grouped by colors. Okay, this k-means cluster may not make that much sense on this type of data that we have, but we just do it as an example, okay? From matplotlib, okay, we use that a scatter plot, okay? For a scatter plot for x and y, we can use reason, okay? I'm gonna put reason and out, okay? Reason and out as an x-axis and reason, okay? And then, okay, we want to show that clustering if that happened with color, okay? For the color, I'm gonna use map, and okay, if they are inside different groups, like show them with changing color, okay? How we gonna do that? I'm gonna use a map, okay? And inside the map function, I'm gonna use lambda and tell that lambda, okay, keep like increasing according to that predict, according to this predict that we did, okay, keep changing colors, something like that. How we do that here? Okay, here I'm gonna come and say there is a map function, okay, this map function, we're gonna use it here for colors, mapping colors according to this predict that my k-means cluster did. Okay. So for the color here, we use that lambda. Lambda was like increasing color, okay, or changing color, like according to value or whatever that they had. Here we're gonna change this lambda color according to this predict, okay. Lambda keep changing according to this x, and the code of color in matplotlib color we check last time together. The code of color, we're gonna use code color 3b 4cc 0, which keep changing the colors increasingly, something like that, okay? And if this x is equal to 1, not changing, so put a different color on that part. If this x is not like changing and it's equal to 1, this value, if x equal 1, then put a different color. Put a different color means else. If x is like 1, else put a different color code on that one. And I'm gonna say, I'm gonna use the code of that color, okay, which is B40426. According to what this color gonna change, according to this predict, okay. Instead using this whole line of code, you can actually use this whole line of code and put it here. And also we can just create a variable, and like any variable that you want, I create a variable for this line. I put this variable and I'm gonna put it here, P, and that's it, okay. So now I want to put all this line equal to this color. So my color gonna keep changing according to that one, okay? Because I want to see that colors according to each group that we have. Here I'm gonna put all this line inside a list and like put a variable name to make it short, and just use that variable inside that color. Equal to this color, okay, equal to this color. So let's put it inside a list. And let's put like a name for that. A name which is not keyword, okay, just not keyword. Now my color can be colors, and so I want to add that transparency. For transparency, we were using that alpha. Do you remember alpha? 0.5 is the average. Okay. And then here plt dot show. And now run it. Okay, my file is not defined in line 3. My file, it doesn't recognize my file. Oh, do I need to run it again? Okay, let's run the whole program from the beginning, okay? Let's run this. Okay, now it accepted. So it first didn't recognize because we need to go and run the program from the beginning. Okay, now you see we have few different colors on our scatter plot. Okay, it came up and grouped them. I don't know according to what it grouped and cluster them. So you see we have this light pink color, we have this light blue, we have this red, and we have also this one is a kind of like dark blue, something like that, okay? So it put them inside like different groups, the data that we have. And see, that was only one-time clustering. Each time that you run, try to run multiple times this block of the code, okay? Each time that we run it, the colors keep changing. See, the color keep changing. Why? Because we said it keep doing this clustering, doing this grouping till reach to the end of whole data and just go through all data and reach to the point and say, okay, this is the best cluster that we did. Now it started. It keep going. When we run it, it just keep changing, and it's gonna stop when I'm gonna just show all the time one cluster when we reach through the end where it say, okay, this was the best cluster. It review all the data and say, okay, this was best cluster that we found, and that's it, okay? See, something like this. We can change this like data that we have. We can put something else. See how it changed. Like age. We can put age. Let me put age inside this. Age and reason. Okay. Age and reason, then run it. Okay. Inside the age and reason, we have a different shape. And if we keep like running this block of code, so see each time it's gonna change. And now, is it? No, it is still keep changing the color. I can say that. Yes. It keep changing color and continue this. These are all clustered. These are all groups that it found, okay? These are all correct. It's a kind of cluster that the program did, okay? Okay, let's do something for this cluster. This type of data, actually, the example that I give doesn't show or doesn't work that much well on clustering because age and reason, I don't know, but we can do something. Okay, let's do cluster my employees. Okay, I want to cluster my employees who were absent and they're all inside this Excel sheet. I want to see how their absentee behavior was similar according to all answer that they gave, okay? For example, okay, I have all my employees there. And according to row, like they have how many keys, where they live, how far, how much they were paying for like expenses, that distance expenses, and if they're a smoker, they're a drinker, or whatever, okay? According to that answer that gave, okay, how similar they are, group them, group similar employees. I'm gonna say something like that. This makes more sense, okay? Let's go and do same thing. Here I'm gonna do that. Here, let's categorizing whole data set that I have in like how many groups. I want to put all my employees in 4 groups, okay, for cluster. Something like that. Here, okay, I have my data file. We can do this. Okay, I'm gonna tell this program, okay, put all that like each employees to one group and put these groups from 0 to 4 And then add this column, which show the clusters of that, the group of that employees, added at the end of my Excel sheet or Excel file. Okay, I'm gonna create something like that. To do not mess up with the Excel file that I have, so I copy my file and create a new one and do all these changes on that one. Okay, to copy my file, I'm gonna do something like this. Use copy. Copy function is something that copy your file, whatever that you have. Okay, I can say it was my file dot copy. Okay, that's it. And so if we want to do something like that, okay, we need to use a function which is called a scale or pre-processing scale. This scale is exactly like data frame that in pandas we were using. Do you remember? It's supposed to put that data in like arrange column and rows. So here a scale does same thing, but for clustering. Okay, I have my file. I want to put it inside that scale. Okay, this scale actually help for that like prediction to be accurate. But if we don't use it also, it is okay. But it try to make it more like accurate, I think so. That prediction function. Okay, I copied my file. I'm gonna put a variable. For this file, I create a new file. So this is my new file, data. Okay, data. Now I put this data in a scale, in pre-processing scale, okay? Which is like this, pre-processing dot scale function, okay? What I want to put inside the scale, my data, this one, my data that I have, okay? To use this scale pre-processing function, I need to import it, okay? I need to import pre-processing from that sklearn library. Okay, I'm gonna say from sklearn library import pre-processing. Import pre-processing. Okay, I put it on a scale. My data is now on a scale, so I need to keep using this scale data. I'm gonna rename it. I'm gonna put a variable for this line of the code and call it like a scale data. And after that, use my scale data in a function that I want to put. So you remember here we put this my file in per date, in feed and everything. Okay, here I put it my data in a scale. Now I scale it my data. And I want to use this scalar data. I'm gonna call it a scalar data, like data that I scaled. Okay, this is a scale data. I put that for a variable. Okay. Now we're gonna go and repeat that tree function that I told you. K means fit predict. K means fit predict. Okay. Let's use this K means, and K-means was for telling how many clusters we want to have. Okay, I want to have 4 clusters. What time is it? Okay, we have 10 minutes. I want to have like 4 clusters here. If we put the number 4 is also okay. It's gonna count. If we put number like this, you can say from 0, 1, 2, 3. Okay, 4 clusters there. and then I'm gonna keep using this one. So therefore I put a variable. I just call it K. I create this K variable. K dot fit. Fit what? Fit this data scaled. Okay, my scaled data, I'm gonna fit that one, and then now I'm gonna go to predict. K dot fit underline predict. Okay, predict. Predict what? Predict my data underline scaled. Okay, that's it. Now let me tell you something here. In line 7 here, okay, I k-means with for this k is actually this k-means. Okay, I did k-means with for clustering, for grouping. I fitted, then I predicted. Okay, then all done. In this 3 line, all done, my cluster. Now, okay, I want to create a columns. Okay, create a columns and add this data at the end of my Excel file. Okay. Have we mentioned a column? So my data set here is called data. Yeah, I rename it. Here was my that I copied from the previous one, and this is data, the new name that I gave it. So here is the all done like predicting that cluster grouped. Here grouped all my data till here. So I want to put this data in a column of my Excel file. Therefore, here I say data column equal. Okay, this gonna supposed to be equal to one of the column of my data, which is new. I don't have it. New. I gonna add it. So have we just call a column of data? We're gonna write exactly the same thing. So with new name, which we create, like cluster. I'm gonna just call it clusters, okay? Clusters. Now, so we can print or we can save it, okay? We can save this data to an Excel file. I created, but I didn't save it yet. So I'm gonna put it in the Excel file and call it like cluster data. I'm gonna call it cluster data dot Excel. XLSX. That's it. Okay. Here also we can come and just print. I want to see my data here also. Okay, print my data, print this data that updated. Here I update. I added a new column at the end of my Excel file to this data file that I have. Now let's run it. Okay, when we run it, it actually prints out my file, the 5 first rows and 5 last rows, okay, and continue like all data transportation time during per. Well, here, see here, this cluster, it came and put number 0, 1, 2, 0, 3, 2. Okay, let's go and check my file or whatever you put it. Okay, let's go and find this cluster data. Cluster data. How I did it? Cluster data. Am I correct here? Cluster data. Cluster DB. Cluster data. No, I didn't find it. Cluster data. Data launch. Let me print this one. Run it one more time, okay? Run it one more time if you couldn't find your data dot use. Okay, now I see it. Now I found it. See? Let's open Let's open and see if we can see that last column that we added. Okay, we added this column, see? This column came and grouped my employees. For example, I say the first employee in the line 1 is similar with the fourth employee and fifth and also this other two because they are all in group 2, okay? Probably it came and see, okay, they have similar weight or clothes like pet, son, or something like that. So they try to understand and figure out the best cluster that it can, okay? So it grouped it like this. So, and then I have my group 1. So this one is similar and this one is similar to group 1 and then 1. Then I have group 0 and group 3, okay? This was all about clustering. So clustering algorithm is a kind of machine learning algorithm, okay? These are all extra data analysis methods that we learn, and they are advanced data analysis methods that we learn, okay? You may not use them or you may use it. So since we have extra time, I try to explain this kind of like advanced methods of data analysis to you too. Okay, if you have any question, please ask me. Otherwise, we are all set with clustering. We just learned one of them, k-means clustering, okay? And that's it. So save your file. If you have any question, please ask me. Otherwise, see you